Hi all, welcome to another video of the subject power system analysis based on the KTU syllabus, and we are on module 3, and today we will discuss another problem based on the Gauss-Seidel method of load flow analysis. So in the previous video we have learned one problem, okay, and today we are going to learn another kind of problem here where the generator bus is present. So for the system shown in figure, determine the voltages at the end of first iteration by Gauss-Seidel method. Take alpha is equal to 1 and bus specifications are given in table. Okay, so this is our bus and this is our system, and in the figure itself we understood that there will be 4 buses, 1, 2, 3 and 4. 4 buses are there, and parameters of the bus are given in the table. The bus 1 is a slack bus, so its voltage is specified, and bus 2 is a PV bus, that is it is a generator bus, and its P and V values are voltage values are specified, and they have given the limits of reactive power Q for generator bus, and other 2 are PQ buses, that is load buses, where the P and Q values are specified. Okay, so we have to find the first iteration voltages at these 4 buses, that's all. Okay, so initially as we have seen in the previous problem, we have to find the admittance matrix using the same method. Okay, so it is a 4 bus system, so we have to calculate the Y bus with 4 columns and 4 rows, that is Y11 to Y44 we have to find. So Y11, we know that Y11 means the sum of the admittance connected to the first bus. So here the admittance are 1.2 minus J4 and 1 minus J5. So these two are added together for getting the Y11 value. Okay, Y11. Okay, Y11 means Y12 plus Y13. That is the admittance connected in between bus 1 and 3 and between 1 and 2. Okay, so we will get the Y11 value, and Y22 same as we have to add all the admittances connected with the bus 2, and Y33 we will get by adding all these 3 admittances, and Y44 adding these 2 admittances. Okay, and Y12 means Y12, capital Y12 means, okay, capital Y12 means the negative of the admittances connected between this 1 and 2. Okay, that is we can see can clearly understand from this slide itself. Y12 means it is also equal to Y21, and it is minus of Y12. Okay, so minus of 1 minus J5, we will get minus 1 plus J5. So like that we can find any element in this in this matrix using the figure itself. Okay, so at last we can form the Y bus matrix as like this. Okay, so this is the usual procedure we are following for any type of problems. Okay, and next one, in the given system we know that the first bus is a slack bus. Okay, the first one is a slack bus, and the bus 2 is a generator bus. Bus 3 and 4 are the load buses. So the initial voltages of load bus are assumed as, that is these PQ buses are assumed as 1 plus J0. This is the initial voltage we normally assume for load buses. Okay, and for slack bus and generator bus the voltages are specified. That is, for slack bus the voltage is 1.0 is angle 0 degree, and for generator bus the voltage is 1.04. okay, so we can calculate the initial values of all the buses, that is V10, V20, V30, V40, like this. So V10, first bus is a slack bus, so if it is a slack bus case, we know that the voltage will not change for any number of iterations. Okay, it will keep on the same value for any number of iterations, that is for V10, V11, V12, V13, okay, V14. For any number of iterations the voltage of the slack bus, okay, will be same. Okay, and for the generator bus also the voltages is specified, that is for generator bus it is 1.04, so V20, okay, it is also here we are considering as 1.04 plus J00 per unit. And for load bus and for other two load buses V30 and V40. Initial values for other two load buses are, we are assuming it as 1 plus J0 per unit. Okay. So for slack and generator bus, we need not to assume the values because the voltages are already specified in the problem itself. Okay. But in the case of load bus, the voltage will not be specified because we know that for load bus P and Q values will be specified. Other values we have to find. Okay. So this is the initial values we are assuming before the iteration process. And for generator bus, the specified powers are considered as positive powers, but for load bus the specified powers are considered as negative values. Okay. So here for load bus the specified powers P and Q values, it is given 0.4, 0.3 like bit, that all will be considered as negative because it is a load bus, that is it is consuming the power. For generator bus the given values are treated as the positive value. Okay. And for first iteration the value of K will be 0. So in each iteration the slack bus voltage need not to be recalculated. In each iteration the reactive power for generator bus has to be calculated and checked for violation of the specified limit, as we have learned from the step-by-step procedure of the Gauss-Seidel method. Okay, if the limits are violated, if the limits of the reactive power, here the limits are given as 0.1 to 1. Okay, limit of the reactive power is given as 0.1 in between 0.1 and 1. Okay, if the calculated reactive power for the second bus, that is the PV bus, that is the generator bus, is not within the limits, okay, we have to treat this bus as the load bus. Okay, so that is the thing we have to note down clearly. So it is actually written here. Okay, the set information is already written here. So the calculation of bus voltage for the first iteration. Okay, we are starting our first iteration. So for the first bus is a slack bus. So the first iteration value V11. Okay, V11 is same as V10 initial value because it is a slack bus. The voltage is specified. So it is 1.0 is plus J0 per unit. Okay, and for bus 2. For bus 2 is a generator bus. So we have to calculate the reactive power Q2. Okay, Q2 for the generator bus. And we have to check whether the calculated value of the reactive power is within this limit. Okay. So for calculating the reactive power, we are having the equation of QP calculated K plus 1 is equal to minus 1 into imaginary. IM means imaginary part of VPK star sigma Q equal to 1 to P minus 1. This is P minus 1. Okay, this time is P minus 1. Okay, up to P minus 1 we have to calculate for the first time. Okay, and YPQ VQ K plus 1 plus sigma Q equal to P2N YPQ VQ K. Okay, so here the value of P is equal to 2 because we are calculating the voltage for the second bus. Okay, P is equal to 2 and the value of K is equal to 0 for the first iteration. Okay, we are calculating the voltage for the first iteration, so the K value will be 0 for the first iteration. Okay, it is very important. So we have to write these terms, and if you can write these terms initially, then we can simply substitute for K and P and N in the coming steps. Okay, and the value of N is equal to 4 because the number of buses is 4. Okay, so for calculating Q2 calculation, okay, the reactive power Q2, the calculated value of Q2 for the first iteration, Q2 calculated 1. Okay, K is equal to 0 means it will become Q2 calculated 1 is equal to minus 1 into imaginary VPK. K is 0, so V2 0 star. Okay, and sigma Q equal to 1 to P minus 1. So here we have to note down that the value of P is 2. Okay, we are calculating the second bus, so P minus 1 means it is equal to 2 minus 1 is equal to 1. Okay, it is equal to 1. So here the value of Q, so this term is only for the value of Q is equal to 1, that is Q is equal to 1 to P minus 1. So P minus 1 is already, it is 1 here. Okay, so the equation will be P is 2, so Y2 Q is equal to 1 here. Okay, so Y21 and VQ K plus 1, Q is 1 here, so V1 K plus 1 means K is 0, so V11, V21, V11. Okay. And for other values of Q, we have to use this equation, that is sigma Q equal to P2N. Okay, P2N means the values of Q is adopting the values of 2. Okay, it is adopting the values of Q is adopting the values of 2, then up to N. N is 4. So 2, 3 and 4. The Q will adopt the values of 2, 3 and 4. Okay, for these values we have to use this equation. Okay, so YPQ, P is 2 and Q is 2 for the first case. So Y22, then VQK, Q is 2. We are considering the first case. So Q is 2. So V20. Okay, K is 0. Plus, then we are taking the value of Q as 3. So it will become Y23. P is 2, Q is 3. So Y23. Then VQK, Q is 3 here. So V30. Like that, we will get Y24, V40. Okay, and all these values we know. Okay, we know the values of this Y21, Y22 we are already calculated in the admittance matrix, and just substitute that values here. Okay, and V20, we know that the values of V20 it is already calculated here. V20 is 1.04 plus J0 per unit. Okay, so substitute all these values and calculate its clearly and accurately. Okay, use the calculator wisely, and we will get the calculated values of Q2 as 0.1456 per unit. 0.1456 per unit. So this value is within the limit, because the Q2, as per the question, the values of Q2 must be in between 0.1 and 1. Okay, so we have got the value of Q2 as 0.1456. So it is within the limit. So we can treat this second bus as the generator bus. Okay, second bus as the generator bus. It is actually written here. So for the generator bus, we are taking the values of P2. It is given in the question itself. P2 is 0.5 and Q2 we have found. Okay, it is 0.1456 and V20 is 1.04 plus J0. Okay, so since the bus 2 is treated as a generator bus, okay, the voltage value is specified in the question itself. That is, the voltage here is 1.04, but here the angle is not specified. Okay, for the generator bus the angle is not specified, so we have to find that angle also. Okay, so here we are taking the V21. Okay, that is the first iterator values of the voltage of the bus number 2 as the V2 specified. That is, V2 specified is 1.04 and it is the magnitude, but we have to calculate the angle also. Okay, so for that we will calculate a temporary value for the voltage for the second bus. Okay, a temporary value. So for that we are using the same equation here. Vp temporary K plus 1 is equal to 1 by Ypp, the same equation. Okay, and after calculating this, we are taking the angle of this temporary value of V2 as the real angle. Okay, so for that we have to calculate this one. So here the 1 by Ypp, that is 1 by Y22, we know that, and P2 and Q2 it is already given in the question itself, and V20 and this one also. Okay, that is Q equal to 1 to P minus 1 Ypq Vq K plus 1. Okay, so here we are calculating the voltage for a second bus. So the value of P is equal to 2 here. Okay, so Q equal to 1 to P minus 1, we have to use this term, and for Q is equal to P plus 1 to N, we have to use this term. Okay, so the equation for the voltage V2 temporary is this one, and substitute that values here. Okay, and we will get the V2 temporary value as like this. Okay, so here the equation seems like the reactive power equation, but there is difference between this reactive power and voltage equation. So here it is the voltage value, okay, can be found using the equation in that the Q values is Q equal to P plus 1 to N here, but in the case of the reactive power equation it is Q equal to P to N. Okay, that is the actual difference here. Okay, some other terms are also changing. Okay, this is extra term, but in these two terms a small difference is the between the equations for voltage and the reactive power. Okay, so that should be noted. So here after calculating we will get this equation, we will get these values, and we will take the angle, that is 2.05 degree as the real angle here, delta 2 dash as 2.05. okay, so V2 dash, the second bus voltage value, okay, that is first iterated value of the second bus, okay, voltage is V2 spec angle delta 2 dash. V2 spec is, it is given 1.04, it is given in the question itself, and the angle we have calculated now, it is 2.05 per unit, and the rectangular coordinate values are like this. Okay, just we can convert this polar form into rectangular form using the calculator. Okay, so this is the voltage, okay, first iterated values of the voltage for a second bus, and we have to calculate the voltage for the third and fourth bus also. Okay, so for the third and fourth bus are the load bus, so for calculating the voltages for the load bus we can directly use this equation itself. Okay, because for load bus P and Q values are already specified. Okay, P and Q values are already specified in the question, so we need not to find these values. We can simply find the voltage value using this equation. Okay, so V3 dash, first we are considering the P as 3. Okay, V3 dash, so 1 by Y33, 1 by Y33 into P3 minus Q3. Okay, so here one thing you have to note down is this is a load bus, so the given P and Q values are treated as negative here. So here in the question itself, the values of P and Q for a third bus, the values of P is 0.4 and Q is 0.3, but here if you are substituting the values of P and Q for third bus, this P3 and Q3, it is substituted as negative. Okay, that is P3, actually it is given as 0.4, but we have to consider it as minus 0.4, you can see here. Okay, and Q3 also, it is already negative here, so Q3 is positive value, so if you are taking the negative, it will become positive here. Okay, so and here also Q is equal to 1 to P minus 1, P is 3, so P minus 1 means 2, so up to 2 for the values of Q is equal to 1 and 2, we have to use this term, and for further values of Q we have to use this term. Okay, so all other values we have substituted here. Okay, that we know the same procedure. Okay, and at last we will find V31 as like this. So same as we can find the V41 also. Okay, V41 also, using this equation we can find the V41 also, and we will get the values of V41 like this. Okay, and at last we will write the first iterated values of all the bus voltages V11, V21, V31, V41. V11 is already specified in the question itself, and for V21 the magnitude is specified but the angle is not specified, so we have found the values of angle, okay, for the generator bus, and V31 and V41 are the load buses, and we have calculated the voltage values like this. So I hope all of you understand the problem well. So thank you.